HPC is the unsung hero of COVID.
Software in the HPC world is always challenging.
This was the year of exascale.
Computational storage activity.
This notion of HPC everywhere, HPC at the edge.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Well, hi, it's Doug, and I'm with Shaheen again for At HPC podcast. And this is going to be sort of a look back at the last year, at 2021, and maybe some trends that we think will be significant coming up. Next year, we're looking at this as a special double issue of this podcast that will sit on the Inside HPC site for the entire holiday week. Shaheen, it's great to be with you again.
Likewise, thank you. So year in review, and what a year it was. So should we just get started with our let's see how many we get, but kind of a top 10 in no particular order?
This sounds good.
So let's start with COVID. Supercomputing really helped with a very heavy lift of finding a solution for a big global human scale problem, with all these supercomputers getting redirected to understanding what was being dealt with and finding solutions for it.
Yeah, my feeling is that, at least among the general public, way outside the HPC community, HPC is the unsung hero of COVID. A year ago last summer, when it was being announced that we'd have a vaccine by the end of 2020, there was a lot of doubt about that. Some of that doubt was politically charged, and some of it was just the sense of no way, we've never come up with a major vaccine in this time span. But as an editor, I'm constantly seeing information from the various supercomputer centers about the work they were doing on COVID. I was fully confident, based on what I was seeing, that we were going to get to a vaccine by the end of last year, and we did. So it's a great achievement for this community.
Incredible.
It's beyond the supercomputing centers, actually. It's also all the shared compute resources that were put into play. So it's a great story.
It truly is such an achievement. So kudos to all who made it happen, and we all get to benefit from it.
This was the year of exascale, and the first of the 3 American exascale systems, the Frontier system at Oak Ridge National Lab, appears to have been delivered, and installation is now going on. We actually have a story on Inside HPC about possibly, rumors about some issues and challenges they're having with Frontier on the fabric side of things. But overall, DOE and Oak Ridge are saying really things are on schedule. Delivery was this year. It will be up and running for end users next year.
Yeah, no, I expect it to be more or less on schedule as planned. And I think that they've been doing a great job. I think these are obviously really complex systems. And the fact that they started delivering and installing it in 2021 was a major achievement. So I think this is another prize for the community that it did it. And it's wonderful.
Yeah, it's kind of a moon launch, kind of an effort. When you read some of the articles about the amount of electricity that needs to be piped in to the Oak Ridge Leadership Computing Facility where Frontier is going to be housed, the plumbing for the water cooling, it's on a scale that really is amazing. Just amazing.
The whole thing is incredible, and it's a giant achievement.
Another thing, by the way, we really should touch on is HPE and its really impressive string of major systems contracts this year.
Yes, because they just had a 3-for-3 with DOE and then a string of high-end wins after that. The win with Azure in the UK for weather forecasting was a big piece of news this year.
Right, and then the Perlmutter system with 6,000 NVIDIA GPUs, that's an HPE system too.
Right on. Almost like they're the only game in town.
Certainly at that very high end, that kind of is the sense.
So that takes us to item number 3, and that's software. Now, with exascale, one big question is how do you program all this stuff? And it was really gratifying to me to see earlier in 2021 that DOE is allocating funds for the software research parts of it. Now, software in the HPC world is always challenging because if you're trying to get maximum performance, you end up giving up productivity, maintainability, portability, compatibility, all those other good T's, because you're after maximum performance. So you try to optimize the heck out of things, and by doing so, you render the software kind of unusable. So that's a challenge that's going to continue.
Yeah, well, they say hardware is easy, software is hard, which might be a little simplistic, but still has a nice ring to it. But the Exascale Computing Project, since day one, has pushed this concept of capable exascale. It's a whole ecosystem of users, trained users, but also very strong on software, so that these exascale systems aren't just stunt systems that can reach a benchmark. It's really making it into a practical solution that can really do
Right.
great scientific computing.
We need to do a lot more. That software continues to lag and it needs significantly more attention. Now, as I said, there is a difficulty between productivity versus performance, but then you also now have so many options at every level of the stack, from chips to accelerators to the other layers of the stack. When you go to containers and databases and on, languages, and then you have to look at all the modern software engineering tools that are being developed outside of HPC that HPC can take advantage of. And there are things that HPC has done that it can contribute. So I'm hoping that the whole general convergence between HPC and IT will help us do that.
Yeah, and you're complete. I mean, DOE is regularly, routinely making funding announcements around the software in the software area. It's really been impressive. The ongoing convergence of AI and HPC, which we've talked about for a lot of years, but it really seems to be maturing very rapidly this year.
Well, one of the several broken records that I sound like is how AI and HPC are so the same. And I continue to think that the only part of AI that is really moving the needle in a big way is deep learning. And that's the part that is growing fast. And it's all HPC. It's all matrix multiplies, going to 3D differential equations. And now with metaverse and inference and all these other things, it's going to take us everywhere.
Do you see them joined at the hip, or does one lead the other? What's the interrelationship there?
Well, I personally think AI is a subset of HPC. Not everybody agrees. And of course, there's more to AI than just the part that is HPC, but I believe the part that is HPC is simultaneously the part that is very significant and the part that's going to grow the fastest.
And that kind of leads into our next topic, which is the proliferation of chip architectures, ARM, RISC-V, the old standby x86, but also Power. Very, very impressive diversification in architectures.
That's right. Certainly at the CPU level, we've had the x86, ARM, RISC-V, and Power continues to be in the mix. And Power 10 was announced this past year and is a very nice chip. But these are all advancing quite rapidly. But then you also have a raft of GPUs and accelerators that are trying to optimize this part or that part of the AI landscape. And then all of them are really relying on advanced fabrication capabilities. That's TSMC primarily, and then Samsung and their clients. NVIDIA, AMD, Apple, etc., are benefiting from all of that.
Really, a huge story this year is just the incredibly rapid emergence of AMD and NVIDIA in relation to Intel. But those two companies, AMD, NVIDIA, in alliance with TSMC, and I guess Samsung as well, the two vendors, chip vendors, doing the design end, and then the fab coming out of TSMC and Samsung. And
they're both on fire.
The level of execution is so impressive. It's really been phenomenal this year.
And, a few other vendors too that are executing extremely well, but both of those are really highly visible and big doing so. That leads us to item number 6, which is Intel, which obviously continues to be the bloodstream of computing.
And still dominant in data center server.
And a major global player, and even a national security consideration. Now, the big news there was really the appointment of Pat Gelsinger as their CEO earlier in the year, and he's doing a fabulous job helping them regain their voice and bringing some deep techies and making them visible and empowering them to go actually talk about future technologies. That's been really refreshing to see, and I applaud them for that.
One aspect of what I would say is what seems to be a very good job that Gelsinger is doing is that he's a likable guy. He's very good with media. And Intel has had some repair work to do in that area. I think Bob Swan was a very good
class act.
Yeah, class act and a really good transitional figure from the previous generations of leadership. But Gelsinger coming in, self-described geek, a tech enthusiast, and he conveys that really well. I think, part of his challenge is not only on the execution end of turning around this Intel aircraft carrier, but also setting expectations right, because it's going to take quite a while to achieve the mission that he's on.
Yeah, and of course, there's a lot that they can do within their existing realities, and they're doing that. The recent announcements have been really strong. There's a lot you can do within the x86 thing while you're sort of fixing the fab and trying to take advantage of what might be available outside of Intel. They're doing a lot of different things that all feel right and look like they're producing results.
Within the HPC industry, a couple of hot growth areas we've certainly seen this year is the growth in HPC cloud. In a lot of ways, it seems to have kind of replaced or certainly eaten into the old low-end workstation HPC category within the market.
That would make sense, because if you have a small job to run, you might just as well go to the cloud and do it and be done with it. And if you don't have the wherewithal to do your own data center, then it also is simple. I think what we're observing is that as your usage of cloud increases, you start getting to a zone where it might be economically advantageous to have local systems. And if you have any data governance and data custody compliance issues, well, then that adds to that, until you get to like super big status where you can go and cut your own deal with cloud providers and make sure that all those requirements are addressed. But it's definitely growing.
Yeah, we just had an announcement a few weeks ago that Facebook selected AWS as its cloud capability of choice. So I think it's very interesting. Where's that break-even point between HPC class workloads that you run frequently enough, constantly enough, where it makes more financial sense to have that capability at your own data center as opposed to being out in the cloud?
I think burst capacity into cloud has always been like a no-brainer. If you already have your own systems and now you need more capacity temporarily, if you don't have an international footprint like Facebook does or Netflix does, then maybe the pressure to go to cloud is a little bit less. But if you're Netflix and you're trying to stream all over the world, now you need data centers all over the world. And maybe it's easier to go to the cloud.
Yeah, especially on an as-needed basis. Another hot area is this notion of HPC everywhere, HPC at the edge.
That's really the more interesting phenomenon, because now you are seeing everything turning into a computer that is AI enabled, AI infused, and is able to do inference, but also needs to do federated, continuous, global learning. So if that's the case, well, then every device that is out there that is AI enabled is simultaneously doing inference from learning that was done before, as well as participating in federated learning so that it can do better in the future. And of course, if you want autonomy, that's really where you have to go. So edge AI is like emerging, and with it, edge HPC is emerging. And I think that's sort of one thing is like AI at the edge. And then second thing is like how the whole IT is moving from, well, it moved from terminal mainframe to client server to mobile cloud and now to edge to core, where cloud has to share the limelight with edge while both of them will continue to grow.
And with the need for AI level processing everywhere, yeah, means HPC everywhere.
Right on, right on. So item 8 is diversity in HPC, an area that I'm really delighted that the community is getting more and more serious about and paying more and more attention to.
There's sort of a demographic issue in the HPC community that it's getting older and it's already strongly, heavily male. And increasingly, I hear concern expressed about, bringing new lifeblood into the community, into the industry. And the industry really needs a broader divergence demographically of people to draw upon.
Yeah, definitely. And while a lot of really good moves are made, I think we all agree that a lot more needs to be done.
Right, absolutely. Now, within the industry, the deals and acquisitions, a lot of activity there.
Yeah, this was like the year of acquisitions and mergers, right?
Yeah, HPE Craig was finalized,
Uh-huh.
and but we've seen NVIDIA Mellanox, but probably the most exciting, the one that's drawn the most attention, is NVIDIA's attempted acquisition of ARM.
That's right. And of course, we covered that in our last episode or one of the episodes before, where the FTC is now in the middle of it. So we'll see what happens there. But also AMD bought Xilinx. Of course, Intel has had a string of acquisitions. They bought an FPGA company just like Xilinx a few years ago with Altera, but also with Mobileye and Nirvana and Habana and a few others. Then at the same time, Atos bought Nimbix and Microsoft bought Rescale a few years ago. So cloud getting into these bigger players is also happening. So I think mergers will continue as this area gets hot. So by my count, we get to item number 10. And for me, that's storage. I'm really interested and track the computational storage activity that is best exemplified by what's happening at Los Alamos. And they've had several announcements about that over the past couple of years. But really, fundamentally, we see the impact of SSD or storage class memory or non-volatile RAM and VRAM. And the impact of that on storage is being felt across the storage stack. And we see various companies and technologies form to take advantage of that as we move away from spinning disk to flash kind of technology. Now, having said that, spinning disk continues to have a nice life, and even tape drives are back now. As we get to exascale class systems, suddenly tapes have renewed life, and I expect they will continue.
Certainly that whole notion of a hierarchy of data, what's hot and what's cold, how accessible it needs to be, has certainly taken hold in the industry. So that some of the older storage technologies are perfectly good for archive less used data and move up the priority list using different technologies.
Very much, very much. Now let's over-deliver here, Doug. We said top 10, but this is like item 11 or 12, or maybe it's even a baker's dozen.
Okay.
It's interconnects. So we obviously have Slingshot, which is dominating the very high end. Mellanox continues to be a major dominant player as well. But then we have OmniPath that has resurfaced under Cornelis. And then we had a new player called Rockport that's doing kind of a switchless switch by spreading the switching activity among NIC cards. Very intriguing approach. And then you've got all the PCIe players, GigaIO, Liquid, etc. Not to mention all the Ethernet players. But then you also have DPUs and IPUs and whatever other processing unit that you want to label on that do the data movement part of the equation. So that's also very interesting to see, and it all was happening in 21.
So certainly major R&D work being done in Fabrics, which has always impressed me as just mind-boggling how the complexity of the role that Fabric plays in these large clusters. I know Cornelis is pretty interesting, that positioning the old Intel OmniPath fabric as a vendor-neutral HPC class interconnect for an increasingly heterogeneous world. So yeah, it'll be very interesting to see how some of these companies move forward.
And of course, every one of them is going to be a topic we can come back to in 2022. So we look forward to that.
All right, I'm already looking forward to it. Shaheen, great to be with you again.
Well, to our listeners, happy holidays. Enjoy. Hope you get a couple of days off and have fun with family and friends and reflect on 21. And let's get prepared for 2022.
Happy holidays, everyone.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.